In the previous lesson, in this study strategies series, we learned about retrieval strength and storage strength. Storage strength is associated with the strength of the memory trace in the cortex as a result of consolidation processes. So as we strengthen synapses in the memory trace, we're increasing the storage strength. By contrast, retrieval strength was associated with the ease of access of the information, and that was associated with the working memory system. And we said there were two ways then to have high retrieval strength. The working memory boost, whereby we were just processing information, so it's temporarily still there in the short-term memory system and we can quickly get at it, or high storage strength, that we have stored a memory well and so that permits easy access to the information. And remember, we know that access to the information after consolidation events does not necessarily require the hippocampus, as we saw with neurological patients like HM. So what happens when we learn? We're increasing the retrieval strength for the information, and we'll call that the working memory boost. So we're enjoying, during our study session, we enjoy the working memory boost. Then, when biology takes over, if the consolidation processes are successful, we're going to be increasing the storage strength in the cortical memory system. Why can we remember then? Because we successfully increased the storage strength. We successfully increased the synaptic strengths of those neurons that were involved in the cortical memory trace. In this final lesson then, we'll tackle the question, why do we forget, and what does this all mean for study strategies? We're going to introduce another concept called the theory of disuse. Why do we forget some things faster than others? Well, psychologists have postulated an interesting relationship between storage strength and retrieval strength. And we can see it in the following graphs. In the top graph then, we have on the x-axis storage strength from low to high, and on the y-axis rate of loss of retrieval strength, low or high. And what this graph is telling us is that when a memory has a low storage strength, the rate of loss of retrieval strength is high. If a memory has a high storage strength, the rate of loss of retrieval strength is low. So the storage strength determines the rate of loss of retrieval strength. We can just sort of replace this idea here, rate of loss of retrieval strength, with rate of forgetting. So under this theory of disuse, forgetting is about a loss of retrieval strength. So disuse, so when we don't think of information for a while, we forget stuff. Disuse does not lead to a decay in the storage strength of the material. Rather, disuse causes a decrease in the retrieval strength of that information, the accessibility of the information. So forgetting is a loss of access. Now, out there in the everyday public, lots of folks maybe think of forgetting as, well, the memory trace is somehow getting weaker and weaker over time. And these psychologists are arguing that forgetting is more about a loss of access to the information. But importantly, the rate of forgetting is related to the storage strength of the memory in the first place. So again, if we do not store a memory strongly, if we have low storage strength, we have a high rate of forgetting. But if we can increase the storage strength of the information, we will have a low rate of forgetting. Now, we said previously that multiple consolidation events were required to install strong memories into the long-term memory system. Well, from this point of view then, multiple consolidation events will be slowing down the rate of forgetting, because consolidation event number 1 increases storage strength to a certain degree and we have a certain rate of forgetting. But if we can enjoy a second round of consolidation for that same information, we've increased the storage strength, and so we have a lower rate of forgetting, smaller rate of forgetting. And if we enjoy another round of consolidation, we'll have even a lower rate of forgetting. So multiple consolidations can slow down the rate of forgetting. And this, of course, is part of why learning takes work. We have to give our brain the opportunity to do multiple rounds of consolidation if we want information that will be accessible for us in the future. Now, what we don't want to do is have our study sessions with no spacing in between. So they're just kind of back-to-back study sessions. So when the study sessions are close in time, it doesn't permit the separate consolidation events. The information is still temporarily stored in working memory. See, so we don't want to have back-to-back study sessions like this because consolidation is a biological process that takes time, which means we have to allow the brain time for consolidation. Well, that means we have to space out our study sessions. By spacing out the study sessions, after study session 1, the brain has time enough to do the full biological process of consolidation. We get the increase in storage strength, and then later, study session number 2 can repeat that process. We can enjoy another round of consolidation. So we have to space out the study sessions because consolidation is a biological process that takes time. It's now time to put it all together and follow the time course of changes in retrieval strength and storage strength as students engage in studying. So here, notice we have retrieval strength up on top with time and storage strength on the bottom with time. And so a student is going to be engaging in a study session. And you'll recall the retrieval strength is more closely associated with the working memory system, the short-term memory system, storage strength with the long-term cortical memory system. So let's go ahead. Well, the student starts their study session. Perhaps they're reading a book or watching a lesson or whatnot. So they're going to be increasing their retrieval strength for the information. They're loading up that information in the working memory system. And as a result of that processing, remember we said whatever was in working memory has the potential to be written into long-term memory. Consolidation processes following learning can lead to an increase in storage strength, but it's a modest gain. But let's return to the study session itself. As the student is studying, they are going to be enjoying high retrieval strength for that information. Unfortunately, many students mistake high retrieval strength for high storage strength, and then they stop studying. And then they don't retest to see if they will remember it. So in other words, the students sort of think that they already know it. So misconception 1, we think we know it because we can easily retrieve the information during the study sessions. Well, that's because we're enjoying high retrieval strength. But easy retrieval is the working memory boost, not strong storage strength. So you see, there's an illusion here. When we engage in studying and we think we have easy access, we do have easy access to the information, we may inappropriately conclude that we actually have high storage strength, when in reality we're only going to be making modest gains in storage strength after that initial learning episode. So we don't want to confuse high retrieval strength and think that it means high storage strength. Now, the fact that we only made modest gains in storage strength after this first study session means that we're going to be quickly forgetting. Low storage strength means fast forgetting. And students often underestimate how fast they will forget. Because again, it's that illusion, well, I thought I knew it during the study session. The information came readily to mind. And so we underestimate how fast we're going to forget because we may not really realize that we haven't increased storage strength enough yet to have a lasting access to that information. Now, sometimes students say, well, I'm just going to have one really long study session, like in a cramming session. Well, prolonged study sessions with high retrieval strength are not useful because there's very little gain in storage strength. So when retrieval strength is high, further study becomes less valuable. And this is unfortunate. It's another misconception that we think that long study sessions are good, but biology is putting limits on the value of continued study. You see, when we are already enjoying high retrieval strength, it's as if for example, to get biological, the hippocampal synapses have already enjoyed their synaptic plasticity. They can't be increased anymore, those synapses. So there may be biological limits to how much more synaptic plasticity can occur in one study session. So we don't want to just prolong our study sessions. Students often think that longer study sessions are better, but biologically they're not yielding the gains that we would hope for. Now, when we go to sleep after a study session, so sleep results in lower retrieval strength due to the delay. So in the next morning, I might find that, wow, I don't remember that information as well as I did the night before. See, during the study session, we have high retrieval strength. Well, sleep is a delay. That's going to reduce the retrieval strength for the information. The working memory boost is gone. But the sleep process, if it was doing its normal memory processing, the sleep process is going to be participating in the consolidation processes and increase the storage strength. So cortical memory traces should be getting stronger as a result of sleep. So again, notice here, it's a little counterintuitive that just by going to sleep, we're actually helping our memory systems, where we're increasing our storage strength. So students may have the view that, well, what's really important is the actual studying, and I don't need to get sleep because the studying is what's going to increase my memory, but sleep is a key factor in raising the storage strength for recently learned information. Now, the next day, let's say we go to study session number 2, we are going to have lower retrieval strength compared to the first study session. And this is good, though, the lower retrieval strength. So the spacing out of our study sessions is going to force the student to confront the lower retrieval strength at the second study time. And this is good. And sort of counterintuitively, these psychologists argue that forgetting is the friend of learning, because lower retrieval strength here means that when we engage in the second study session, we're really going to be setting up a situation where the brain is going to enjoy another round of consolidation, and that's what's going to boost our storage strength even more. So lower retrieval strength is a good thing. We want to space out our study sessions that make it difficult to retrieve the information we were studying the night before. And as we restudy, we're giving the brain an opportunity to do some more consolidation, and that will boost our storage strength. So spaced study sessions will be able to increase storage strength more than extending the original study session. The effects of consolidation processes can accumulate if there's a delay between the study sessions. Again, we don't want to keep on studying here because consolidation is a biological process, and we're not allowing it to happen if we keep on engaging the study material here. We want to space out our study sessions. Sleep is also an important process there, but by doing so, we're going to be giving the brain opportunities to boost storage strength for that information. And notice, when we boost the storage strength for the information, the rate of forgetting slows down. So high storage strength means slow forgetting. Notice the slope here is more gradual compared to here. So here we have a steep slope. We will forget quickly because this was our first study session with low storage strength. But because we've been boosting our storage strength, we've allowed consolidation and sleep. Now we have high storage strength, and so the rate of forgetting is lower. So increases in storage strength require multiple consolidation events, which must happen over time, preferably with episodes of sleep intermixed. Spaced study sessions lower retrieval strength and set up repeated opportunities for consolidation. Notice that once we have high storage strength, when we go to sleep, it no longer then negatively impacts our retrieval strength like it did after the first study session. So after the first study session, we saw a significant decline in retrieval strength. Then the next morning, you might not remember what you studied the night before, even though there was some gain in storage strength. But once we have been boosting our storage strength, now sleep no longer causes such a reduction in retrieval strength, and we can remember the information following a night of sleep. By definition, cramming is a single study episode just prior to an assessment. As such, it cannot lead to large increases in storage strength because the brain has not gone through repeated retrievals and reconsolidations, which are the keys to long-term retention of information. The low storage strength after cramming means a higher rate of forgetting. So cramming might get you through the quiz the next day, or whatever the assignment is, but down the road, you're going to have nothing to show for it. So the implications for good study practices are the following. We have to set up repeated rounds of consolidation in order to strengthen cortical memory traces, which means we have to get sleep, because memory processing occurs during sleep. We have to do repeated study, and we have to space them out so that there's time for the biological process of consolidation to happen between study sessions. And finally, and we'll say more about this in later lessons, retrieval practice. That is, when you study, you want to be trying to actually retrieve information from your long-term memory system rather than rereading or rewatching a lesson. Retrieval practice has been shown to be one of the best practices in helping the brain store lasting long-term memories.